Swayam Prabha. Digital India. Educated India.
So I did my bachelor's in mechanical engineering from Gujarat, and I did my master's in CAD/CAM from Pune. So I have published 5 research papers in international journals and conferences, and I have almost 6+ years of professional experience in the field of CAD/CAM and development of CAD/CAM softwares. So currently I work as a developer in the Spatial ACES 3D geometry kernel. So this is the major geometry kernel, commercial one available out there. And I am working in that field. So I'm also machine learning and computer vision enthusiast at heart, and I want to implement these concepts in the CAD/CAM industry. So most of you might have known that still the application of the machine learning in the CAD/CAM industry is not well defined, or you can say it's not available. Uh, Means it's just you can say academic point of view. We are having the research papers based on that. It shows we can, but the actual productization of that is still not available widely in the CAD/CAM industry. So my aim, or you can say my goal, is to meet these two ends of the strings. So this is my GitHub profile, and this is my email ID if you need to contact me. Okay, so what we will cover in today's session. So the first session, or you can say the morning session, would contain mostly the presentation, and the second session, afternoon session, will have some hands-on lab using PyTorch. So we'll go over what is actually artificial intelligence or machine learning. So brief overview on that. How this is classified, what are the levels of classification for these algorithms. We'll just introduce ourselves with what is deep learning. Then we'll go into introduction of graphs. So the main highlight here, what we want to discuss is the graph neural network, which is a part of geometric deep learning. So for that, you need to have some basic understanding about what are graphs and how it will be used in our graph neural networks. So this is geometric deep learning layers. So this is not just one algorithm, geometric deep learning. So it is basically a combination of multiple architectures that are out there, and they have just summarized them as geometric deep learning. So there are different types of layers or different types of architectures that are used for this. So we'll not go into detail. I will just briefly overview two of them, two of the layers that are most popular right now. And we'll go with the geometric deep learning examples, or in general AI or ML examples in CAD/CAM industries. So I will show a demo of 2 or 3 videos based on where AI and ML is used in the systems. Okay, so we'll start with the first slide now. So what is artificial intelligence and machine learning? So whenever you as a beginner heard about the term machine learning and artificial intelligence, what does the first thing comes to your mind? So do let me know, what does hearing machine learning and artificial intelligence comes into your mind? Anyone? So you can just type in the chat window, what do you mean by machine learning or artificial intelligence? Just one word that comes to your mind when you heard this term. Okay. So Vignesh says some creative statistics. Anyone else?
Participants, you can also unmute.
Yeah.
That might give Aditya a good feeling also.
Good. Yeah, so if you interact, then it would be way better experience. So
A
Shubham says
machine
Google.
learns a machine learns from the previous data that what it have, and then
Oh,
create a model, and
okay,
based on it gives the it take decision on the data which we will provide while we are testing it or in the
okay,
real world. Yes.
okay. So this is basically the theoretical definition of the machine learning, right? But if you are novice, so you can say if you are in general don't know about the term or the definition behind that, and when you see the term machine learning and artificial intelligence, right? So some might may say Google, or you can say the uh, Siri, Alexa, Cortana, the virtual assistants. So these are very popular right now. So even if you have a Apple mobile and you say, okay, Siri, and then you start with the search term, then it will provide you uh, whatever you want to search for you. You just have to ask him or the virtual assistant what you require. So this is a very good example where AI/ML is being implemented, and this is the most vastly developing field right now. The natural language processing and all the stuff is based on them. So there might be some who are thinking as robots, where robots are basically the product of artificial intelligence, and very own our Chitti robot and the iRobot or Terminator. So those are very, you can say, very futuristic thinking of where AI and ML will come into picture. There is again this Tesla self-driving car, or you can say nowadays multiple companies are working on the self-driving cars where lots of things needs to be considered while driving, because it's not safe to just automate driving because there are various factors, and self-driving cars in India so that would be very difficult because we ourselves do not follow our rules. Then how we expect the machine to follow the rules that are there? So as you can see in this particular image, so there are three cameras that are working. There is again a lane detection that is happening in the background. There is obstacle detection that is happening. So multiple things comes into picture to just make this product work using the AI and ML technology. And that's not an easy job. So it's very difficult to generalize this model in practical. And yes, so as Vignesh suggested, statistics, or you can say maths. So behind artificial intelligence and machine learning application, there is a whole lot of maths involved, statistics involved, linear algebra involved, and that is the main backbone of this AI/ML. So nowadays, most of the field is so hyped that no one wants to learn the maths behind them or how it is working behind them, because it's very easy to now create new models on based on data. Even without understanding, now using AutoML, you can just create a model where you can detect faces, and you can just get a new AI based application very easily. But the core research point of view is the maths behind that and how that is come into picture. Yeah, so this is basically what we mean by AI ML. So now, so there are three terms: artificial intelligence, machine learning, deep learning. So what exactly that is? So artificial intelligence you can consider as a whole. You can say the most outer bubble of the stream. So it basically is a way to build intelligent systems which can think like human. So currently thinking is the just speciality of human beings that we can react on that thing. So we try to evaluate, or you can say simulate this type of behavior to the machines. So this is the whole entire field where artificial intelligence come into picture. And this is the, you can say, superset of everything. This is the main thing, and inside that all the different types of algorithms come into picture. So Machine learning is a subset of AI, artificial intelligence. So as Darshil suggested, we learn on data, we provide data to model, it learns it, and then we use it for prediction in the future, what happens. So that is basically machine learning. So we teach the machine in such a way that it will try to predict based on the past data that we have provided. So machine learning is just a subset of artificial intelligence. And finally, the deep learning, or you can say neural networks. So it is again a subset algorithms of machine learning uh, bubble, you can say. So here we use neural networks to determine, or you can say achieve complex predictions, which are not just easily possible in the standard machine learning algorithms that are available. And this is based on how a human thinks, or how the information is processed in the minds of human being. It is based on that. So deep learning, or you can say deep learning means there are we'll go into exactly what exactly deep learning and neural network difference is, but you can say it's a part of this deep learning bubble. So this is what AI, ML, and DL. So these are the difference between the three terms that we in general regularly use interchangeably. So now I want to ask you how a machine learns. So actually Darshil has just answered that question, but I want to know again, what are the things required so that we can make the machine learn the data?
Uh, we need data, then
Correct.
we can create a statistical model, uh,
Okay.
and then based on that model we will predict our real time world data or test data.
Correct. Okay, so you are absolutely correct, Darshil. So first thing that is required is the data, or you can say the data set. So what is data set? So the machine learning algorithms are trained on special kind of, you can say, information, and that information is basically called as data set. Now the data set are basically, we divide the entire data set we have into multiple sections, basically the training, validation, and testing data set. So the data set can be anything, any information. For example, there that might be numbers, sequence of numbers, that might be sequence of images, text that is used in natural language processing, and any such kind of data. So all that comes into the part of data set. So one thing that is required for machine learning is data set. The second thing that is required is features. So now the raw data that we have is not suitable to predict exactly what we are trying to achieve. So we want to find some special, you can say, speciality in the data that we have, which will differentiate between the ordinary data and the data we want to predict. So that is where features come into picture. So from the data set that we have, we find out special features that we need to detect so that we can get the final output. So these are features that is required again for the machine learning. The another thing is we feed this particular information in different algorithms. So I will just go over after this. There are so many algorithms in machine learning. So it is impossible, or you can say it's very hard to know all the algorithms in detail. So we feed this data to this particular sets of algorithm, will then predict the output. So depending on the algorithms, the accuracy might be different. Some algorithms would be suitable for some type of work. For example, for clustering, we basically use k-means clustering or other type of clustering algorithm. But the same algorithm would not be good for predicting the regression analysis, like predicting the stock prices. So all the algorithms are different in some way, and they are suitable for some type of work and not all types of work in general. And once all this data and algorithms and feature you have, this is used to train the model. And finally, what we get is the output, or you can say the prediction. So for example, this can predict the stock prices in near future. So if the model is trained on such data, and this is what machine learning, or you can say machine, requires to learn from the data. So now we'll go to the evolution of AI. So this is not a new term in general. So the concept or the theoretical definition of artificial intelligence was defined way back in early 1950s. So at that time, the main limitation was that we had very little amount of data, and the computing power at that time was very less, which was unable to satisfy the requirements of the so-called artificial intelligence at that time. So in the early 90s, we started getting new machine learning algorithms which were suitable for computing power at that particular point of time. And we had slightly more amount of data compared to what we had in 1950s. So the classical machine learning algorithms like regression, logistic regression, classifier, all that came into picture in early 90s, and that started creating the hype of machine learning in general in the early 20s. So in the early 20s, or you can say around 2010, we had again a large variety of data, and also the size of the data was huge. And the computers were evolved in such a way, we had GPUs at that time, and GPUs just started coming in, which then increased the scope of this machine learning, or you can say the artificial intelligence that was termed in 1950s, to actually practically come into picture using this new computing power that we had. And the evolution of deep learning models came into picture. So in the present time, we have got so many types of GPUs, so much of computing power, and the data is also available everywhere in large quantity. And this is the place where we have now started using applied artificial intelligence. Now, as you can see, in almost every field, in every company, every industry, they are now focusing on the field of artificial intelligence and machine learning, because that is the near future of every industry. Everyone has to go through this thing now, because everywhere you look, there is machine learning or artificial intelligence involved. In the smartphone that you have, a lot of computing power is there, and a lot of machine learning is actually embedded in that thing. Now, even Apple has now started implementing the neural engine in its hardware itself. In the iPhone itself, there is a special processor which processes the neural network stuff. So all the major industrial partners are now focusing on this thing. So we are at this stage now where we are applying the concepts or theoretical concepts that we have learned so far in the research field to actually implement in the productize this particular stuff. Okay, so now we'll go to the classifications of AI, ML, and DL. So these are just high-level classification. So if you see artificial intelligence, so artificial intelligence are majorly classified into three categories. First is artificial narrow intelligence. This is called as weak AI. And currently we are at this stage. So here it has got very narrow capability, or you can say it is based on task. And this is the present stage where we are. We are just implementing one algorithm to, you can say, do one task. So it has got that narrow capability where it just focuses on one task. The other is artificial general intelligence. So this is the place where we are moving forward to. And this has got a general capability, or you can say it can do two or three stuff based on that, and not just one task. So it has got a general capability to understand the environment near it. And this is where we are going in the near future. The third and the final thing is artificial super intelligence, or you can say strong AI. And this is where the things that are shown or that are shown in the movies, like the Chitti robot, or you can say the Terminator. This all have the transcendent capability. So they can think for themselves, and they can just do not do the task just that they are assigned to them. They learn from that, they apply it, and they again develop themselves by themselves. So no human intervention is required for that. So this is called artificial super intelligence, which is way near in future. So it's not in near future, it's very far. So we are just at the first stage of artificial narrow intelligence stage. Now, if we classify the machine learning, so machine learning is majorly classified into three categories again. So one is supervised learning. So this is also known as task-driven learning. So here we have a labeled set of data. So we have already got a data which is labeled. For example, if you think between cats and dog, so you have got images of cats, and we know that this is cat and not a dog. So that is already labeled data that we have. And these labels allow the algorithm to find exact nature, or you can say exact relationship between them, right? So this is supervised task driven machine learning. So there are various algorithms. These are just a handful, or you can say subset of the algorithms. For example, support vector machine, decision tree, nearest neighbor, logistic regression. These are very famous logistic regression, and those are used for stock market analysis and predicting the price of some product in near future. So this is supervised machine learning. Another one is unsupervised supervised machine learning. So this is basically a data-driven algorithm, or you can say. So here we don't have labeled sets of data. So all the data is unlabeled, and we want to find out a relationship between them, even without explicitly specifying what type of data it is. So this is again, there are many algorithms, but K means clustering, as I mentioned already, principal component analysis, singular value decomposition. So these are just some of the algorithms that are under the hood of unsupervised learning. Now there is one type of learning which is mix and match of both. So that is semi-supervised learning. So it is best of both worlds, you can say. There are some labeled examples, and we use that to label the unlabeled examples. So it basically combines the best of both things. So advantages of both the things are there here. And again, it falls between the supervised and unsupervised category. So these are some of the algorithms that are there in semi-supervised learning. That's self-training, co-training. For example, if you have got some set of test data which are labeled, we used to develop a relationship based on that labeled data. And we have got some unlabeled data that we need to classify, or you can say label those data. So then that knowledge that we have you can say occupied based on training of the labeled data, will use to classify this into, you can say label those data there. So that is self-training and co-training. And the third, or you can say the fourth thing, is the reinforcement learning. Now this is currently in very boom, or you can say industries are working a lot on this reinforcement learning type of problem. So it basically learns from error. So here also we don't have got the data that is labeled, but we try the machine to learn based on the errors. For example, a game of chess. So in the game of chess, yeah, it will run the chess multiple times and see how it will reach the final aim, that is to win the game. And based on the experience that the algorithm gets, that is basically used to get a stable model where even the environment is considered. So this is a lot more important nowadays, and this is used for research a lot compared to other algorithms mentioned here. So it tries to improve itself based on trial and error. So it tries to know that no, taking this step has got me a disadvantage. So in future, when I come at this point, I will not use that step. I will instead go to the other way. So same thing happens here. And these are some of the major algorithms that are available: the Markov decision process, Q-learning, genetic algorithm, and these are just a subset of that. Now, a very good image that I found on the internet, which just, you can say, gives a glimpse of where such algorithms are used. So, just a second. Okay. So this machine learning, when we go to supervised learning, so as I already mentioned, we have got label set of data in this particular section. So it is majorly subdivided in two tasks. One is regression task and other is classification task. So in regression task, what types of application can be done? For example, advertising popularity prediction, the click-through prediction, weather forecasting, sales marketing forecasting. So such type of problems are assigned, or you can say can be tackled using the regression side of the supervised learning. Now, the classification side are basically the image classification, where we want to classify the image is cat or a dog. So such type of example are there in classification side of supervised learning. Fraud detection, and email is a spam or not a spam. Customer retention means will this customer will be retained, seeing the behavior or pattern. So such type of application is comes under the hood of supervised learning. In unsupervised learning, so there is dimensionality reduction. So this is very important technique where we have got a feature of very large dimension and we want to reduce it so that the complexity of the problem is reduced. So for that, this particular sets of algorithms are used. And these are just a subset. There are multiple more algorithms available. Again, clustering. So in clustering, basically a recommender system where when you go to an e-commerce website and you buy one thing, so based on your buying pattern, it suggests you different more products. For example, if you buy a mobile phone based on such an company, the next time when you log in or you just visit the e-commerce website, multiple different types of mobiles would be there as a recommended thing that you have bought this product. Now, do you want to buy another product similar to that? Or for example, if you buy a mobile phone, do you want a charger or an earphone based on your buying pattern? So this all things comes into clustering, or you can say recommender system algorithms. The reinforcement learning is majorly currently used in the gaming side of the market, or you can say industry. A game AI skill acquisition means this is used for analyzing the candidate before coming to an interview. Is it applicable or not? The game AI means nowadays the modern games are so well advanced and they use that. So every time you run the game, it would not be the same thing. There would be so many randomness involved in the gaming that this is been achieved using this reinforcement learning, or you can say the machine learning behind the game engine that is used. So this picture basically summarizes the usefulness of machine learning in different industries. So now we come to deep learning and classification of that. So the most simplest, you can say, neural network is the artificial neural network or multi-layer perceptron. So it has got a single hidden layer in this artificial neural network. In total, there are three layers. One is the input layer, the hidden layer, and the output layer. So this expects input 1D input, and this inputs are then passed through the hidden layer, and that is then used for the prediction and the output layer. But this has got some limitation. We'll just see those two limitation in next slides. But one is that it cannot capture sequence information. For example, in the natural language processing, this is the major limitation, because when we speak some sentences, so in that sentence, the one word is dependent on the few forward words and few words that we have spoken. So that integrity or that sequence information, it cannot be captured by this artificial neural network. And on what data it is suitable? So it is suitable for tabular data, image data, text data. So such data are, it is suitable. So even for image data, for small image, it is good, but for large image, as it expects 1D input, the amount of input or amount of neurons in the hidden layer increases so exponentially that it basically it takes, you can say, it becomes more complex rather than getting simple. To overcome that limitation, we have got convolution neural network, CNNs, that are way popular now, and in everything, in face detection, in your face unlock, everywhere this convolution neural network is now used. So this is most suitable for the 2D data. So it consumes the image directly rather than converting it to a 1D image. And this performs convolution that will go into some basic example of convolution. So this is just various types of filters are applied on that to extract that features which differentiate between the inputs. So this is majorly popular for image data and the text data. Recurrent neural network. So this is the main backbone of the natural language processing that is there. So it has got a self connection, or you can say a recurrent connection to the hidden state. So even the previous inputs, or you can say previous information, is passed to the current processing. And that is why we are able to capture the sequence detail that was missing in the artificial neural network. On what data it is suitable? So time series data, text data, audio data. So this is where natural language processing is most popular. The final is the graph neural network. So again, deep learning has got way more architectures and types, but for major classification, these are the three major classification. And current one is the graph neural network. So there are other things, but we'll just concentrate on graph neural network for now. So it is suitable where we have graph as an input and not an image or a text data, but a graph, and that is being used for inference and to get the prediction what type of graph it is, or we'll go into detail about this. So yeah, majorly non-Euclidean data, network data, mesh, points, etc. So this is what we'll be going in detail in this session.